So this is a farewell to ORMs. We're going to talk about a few major pillars of functionality in ORM libraries. Firstly, schema. Kind of the first thing you do when you start using a new ORM is to actually use some sort of syntax to declare typically an object-oriented schema. Migrations. So this is not true for all ORMs, but many of them these days try to be the single source of truth for your application schema. That means that they have to have some concept of migrations in order to actually let you evolve your schema. And finally, they've got some sort of API that lets you do typically pretty basic CRUD operations, and if you're lucky, some aggregations and grouping as well. So here, we're going to be using Prisma as sort of the point of comparison. It's a TypeScript and JavaScript ORM. Actually, something that you'll notice here is that they actually define their own data schema definition language. So this is using their schema, their Prisma language. You're actually able to generate clients, I think, in a couple different languages now. So this is a really basic sort of user blog post schema. As you can see, both user and post have a required ID property. We've got an ability to fetch the posts of a given user and the author of a given post. This is what the equivalent schema looks like in EdgeDB, in our schema language. And there's a few things to note here. Yes, EdgeDB's schema is dramatically more concise. There's a couple of main reasons for that. We don't need to include that ID property. That's one of the fundamental design choices that EdgeDB makes, which is every object in the database has that required UUID property with a uniqueness constraint right out of the gate. And because we know that every object has that ID, we don't need to futz around with foreign keys. We can just say, this object has a link to that other object. We know they both have IDs, and we know under the hood how to actually store that. Prisma, on the other hand, you specify this posts relation, which is how you fetch the posts of a given user. And then we have this post, this author link, which is how you fetch the author of a given post. To their credit, Prisma is sort of implicitly acknowledging the limitations of the abstraction that they can provide here. And they do that because you still need to specify this author ID field. They don't want you to have too much distance from the underlying data model as it's represented in SQL, because they know that there's a lot of things, a lot of queries you can't represent with Prisma's CRUD API. And so they actually have you specify that author ID foreign key and then use this @relation directive here with a couple of arguments to sort of wire everything together. All of this goes away when you just commit to the graph relational schema in the way that EdgeDB does. Now, that shows how EdgeDB can do the same things as ORMs in terms of data modeling. But of course, it can also do dramatically more, things that you could never really conceive of in any sort of ORM that we're aware of. And the crux of that power is simply this. Inside of your ESDL files, where you're defining your schema, you have access to the full power of EdgeQL. It's all there. In fact, SDL is a superset of EdgeQL. So you're able to write entire queries inside of your schema. And there's sort of a gut reaction that certain longtime ORM users have about computed properties, stored procedures, things like that. In the context of the workflows that you typically see with SQL databases, that makes a lot of sense. If you don't have some canonical representation of your schema that is declarative and that you can read, then yeah, you end up in this weird situation where it's difficult to know what computed properties have been declared, what stored procedures are in your database, because your schema is basically smushed across a bunch of SQL migration scripts in a lot of cases. You're not able to just see what the current state of the schema is and read it. It's like if you were trying to write a program and you had to, exclusively write your code as a sequence of git diffs or something. That's sort of how it feels to kind of mentally track your schema in SQL. in a scenario where you don't have a declarative schema. So let's just quickly run through some of the things that you can do when you're modeling your schema in EdgeDB. This is pretty simple, another blog post type here. But we're actually in this required property title, we're adding in a custom expression that actually makes use of one of EdgeQL's standard library functions, in this case, one for actually doing regular expression testing. So we've got this first argument here, and then we pass in the first letter of __ subject, which is just a way to reference the property on which this expression, this constraint is defined. So what this does is it enforces that the first letter of our blog post title is capitalized. Let's take that another step further. We can declare constraints not just on individual properties, but also on objects as a whole. So here we've still got that title property, we've got a published property, and an optional content property. The reason it's optional is when you first create that blog post, let's say our application has a form where you type in the title of it and hit, create blog post, and then it pops you into an authoring interface. Initially, you may not have any content there. But we want to make sure that the user doesn't accidentally publish a blog post that doesn't have any content in it yet. So what do? We actually add a constraint onto this entire object type. So one of two things has to be true. Either content has to be there, or the published has to be false, which means that you can no longer have a blog post here that's both published and lacking content. If that's possible in an ORM, I haven't seen it, but if it is, actually let us know in the Discord. Another thing here, we're showing off computed properties here. We've got that same blog post with the title, and we're actually generating this slug, which is what's going to be used in the URL of our hypothetical blog CMS here. So we're going to take that title. What this stir lower function does is, as it sounds, it takes the title and converts it all to lowercase. And then we're going to be using a regular expression replacement function to take everything that isn't just alphabetic character and replace it with an underscore. Not only that, once we have this defined, sorry, that's the formatting change there, but it's the exact same code for that property slug. Now, what we can do is just add an index on that computed property slug. A pretty common thing we're going to be wanting to do is pulling a slug out of some URL of an incoming request and quickly looking up the blog post that it corresponds to. Well, we can do that now entirely with this computed property, and that query that we run is going to be really fast because we'll have fully indexed on the slug of all these blog posts. Of course, there's other things like Victor mentioned in his talk, which is we can have links between different types and can actually traverse those links in the forward direction or the backwards direction. And there's no special API here for declaring the backlink. It's just a computed property like any other. We're using EdgeQL syntax here. We're using that expression and kind of assigning it to this computed blog posts link. And there's no, we're just using the primitive concepts that EdgeQL gives us and using them in our schema to do things that are complex or useful, such as the ability to traverse these links in the reverse direction. And of course, we have the ability to have abstract types, full schema mix-in support in EdgeQL, which in scenarios like this one, let's say we want every blog post to have a comment section, and we want actually a hierarchy of comments where each comment can have comments. That is preposterously easy to do in EdgeQL, and preposterously difficult to do in a lot of other scenarios with an ORM. So that's the quick rundown of schema modeling. This didn't even get into, I'm just realizing the concept of link properties, which Victor alluded to. Because we've got that graph relational model, we can actually attach properties to our links, which opens up a whole new universe of ways to model data. Okay, but moving on to migrations. There's really two options that ORMs have. They can either actually try to be that single source of truth, like I mentioned, and have a migration system, or they could not. either way, you kind of lose. If they roll their own migration system, there's no standardization to it. They have their own way of representing migration files in their own workflows for creating or executing them. And you end up with a very fragmented experience. If they don't do migrations, then you're also kind of stuck because you've got to use yet another tool to write your SQL migration scripts with ups and downs and executing those. And you end up with another layer of complexity in your stack. Of course, the root of this problem, of all these problems, is that SQL doesn't have a first class citizen concept of a migration. Well, that's not true in EdgeDB. In EdgeDB, every migration you execute is automatically tracked by the database. The actual migration plan itself is generated by EdgeDB, like I mentioned in the live demo. You basically write your schema on your local file system, and when you run EdgeDB migration create with the CLI, it kind of sends those files up to the server, to the database, and it figures out how to actually modify its own schema. And yeah, there's an official workflow. We've got the CLI. You run these commands, and it's the same everywhere. It's the same no matter what language you're using or what framework. It's just a unified developer experience all the way down. And now let's jump into the actual APIs here. This is really the meat and potatoes of why ORMs exist and where they really provide value. You can kind of summarize. I'm trying to summarize what ORMs really do in terms of functionality, what sort of functionality they provide, as concisely as possible here. This demonstrates a pretty simple query. You're fetching some movies. You're able to add some filters onto that query. Here we're filtering based on the title. You can tell it what fields you want to select. In this case, we're selecting titles. You can nestedly fetch related properties. In this case, the movie.actors, which is a massive win. We're certainly not denying that ORM libraries solve real frustrations and problems that people have. One of those is writing any sort of nested query and having to deal with join syntax in SQL. That's a problem that ORMs have solved pretty conclusively. So we're able to actually fetch those related actors, and then we can also add some additional filters even on those related objects. And there's going to be some sort of create, update, delete function. Some of the properties of what these APIs share across all ORMs, they're code first. You're writing your queries not as strings, which is common in SQL. You're writing them with code, which is inherently desirable for a lot of people. They're object-oriented. You can fetch that nested actors, those related actors for a given movie, no joins required. And it's idiomatic. This means different things in different languages, but in the context of say TypeScript, that means that you're getting back a strongly typed result from your queries without having to separately declare the static representation of your query result and a runtime version of your query as well. Now, we're going to be talking about the query builder as promised, and I'm going to be explaining how you can essentially match the functionality of what you do with ORMs, and then quite a bit more beyond that. So I'm going to go ahead and switch over to a little demo environment here. So this is going to be a demo environment that contains a movies data set. You'll see which movies here in a second. Sorry, I kind of forgot to do this bit. Okay. I also have a kind of front end here so we can kind of see what's going on. That's just another simple application, which I'm going to open up right here. Back in localhost again. All right. And then I'm going to open up the actual code. So here's the queries that we're going to be writing. Sorry, should have done this before. We're going to be writing queries inside of this query.typescript file here. And this is actually, all these queries are going to be relying on the schema that Victor built up in his talk, which is that Netflix schema we were referring to. So we've got a person type, we have an abstract content type that's extended by movies and TV shows. So let's jump in and write some queries. A question that you'll get a lot when you start building a query builder and saying things like, we're killing ORMs, is what can you represent that ORMs can't? A lot of times the temptation is to go into the real complex stuff right out of the gate. And we are going to do that, but I'll give you, here's one that you can't represent in any ORM that I'm aware of, which is just selecting the literal string hello world. And this is sort of an interesting point here, which is that because we are a query builder, we represent the semantics of EdgeQL pretty faithfully. EdgeQL has a whole type system. It has a whole concept of sets. It's got lots of operators. All of these basic elements of the type system, this is a very thin layer on top of EdgeQL. So we still have representations of all of those. If you know EdgeQL, you can actually learn the query builder really quite fast. So e.select hello world, you can see that we are writing this query, executing it, and returning the result. That result is going to show up over here just in a JSON format. Let's see what else we can do here. First, we can start using some operators. So instead of just hello world there, let's use one of those functions we saw earlier in this talk, string upper, and see what we get from that query. It uppercases it. Now we can look at using some operators as well, which is another thing that you saw in the to-do talk. So let's go ahead and try, let's see, maybe hello world. I like, which is a type insensitive like operator. And then we can just check if the word hello shows up anywhere in there. And that should return true, false. Okay, whoops, that should be a percent. There we go, true. Something to note here, as you can see, the result here is now a Boolean, which means that we're actually inferring the type of this EdgeQL expression here. It knows that when you do, some string, I like some other string, the result is going to be a Boolean. Whereas if we do something else, say 2 plus 2, whoops, 2 plus 2, then yeah, it's going to know that that result is a number. But if we switch this to 2 greater than 2, well, it's back to a Boolean. Every query I write here moving forward is going to be strongly typed, and that type will be fully inferred by the query builder itself. All right, let's move a little beyond this simple literal stuff and select some movies. So e.select e.movie. This is represented precisely as the EdgeQL query select movie. So just as with that query, by default, it just returns a big list of IDs to us, like so. That's not super interesting to look at, so let's go ahead and fetch some properties on there as well. So title, true. And we've got every single MCU movie. Yes, I did spend solid 2 hours last night populating a database of Marvel movies. That's how I chose to spend my time. So we're fetching that title now. Let's add a filter to it. And because, as I mentioned earlier, if we're going to be doing something like filter.title equals the Avengers, we're going to need some way to actually reference this title property. And again, the way we do that is we actually add an argument into this function that we're passing as the second argument to e.select. And then we can just do something like e.filter. We're going to be using an operator like we used before. Get full autocompletion here on all of the properties and links of that movie, equals, and the Avengers. Something to note before we run this query. Note that the query results that we're looking at from before are an array of objects. Now, when I run this query, save, run, you see that the result is actually a single object. That's one of the most interesting and hardest to implement parts of this query builder, which is it knows that this title property here has an exclusive constraint. That means that only one movie in the entire database can have the title of the Avengers. So what it does is it knows that this expression here is an equality expression. It's checking for the equality of an exclusive property with some literal value. And it knows that when in that particular situation, it infers the cardinality of the results, just as EdgeQL does as well. If we started change this away from equality to something like I like, which could match potentially many movies in the database, you see that the result is now back to being an array. And indeed, this changes to an array as well. All right, so let's switch back to just fetching the Avengers and start looking at some nested fetching. This is all definitely in the domain of ORMs currently. So we can go ahead and pull in those related actors, just like we did before, and their names. Return that. And we've got Avengers with its full set of actors there. Here's something that's a little trickier, or at least less pretty, less pretty to do with ORMs, which is we can fetch that character name as well. Since that is, we can just track that as a bit of metadata on the link itself. Another thing, we can add in these computed properties, which I mentioned a little bit in the FAQ section from before. So yeah, something to point out, title and actors, they get auto-completed because it's a link and a property of the movie object respectively. This filter key also gets auto-completed. In fact, you can see there's a few operations we can drop in, like filter, we can do order bys, we can do limits and offsets as well. But you can actually put anything you want in here in these other keys as well. So let's do uppercase title, and then we can just drop in really any EdgeQL expression that we want. So let's do string upper movie.title again as a demonstration of this. And you can see that in addition to the Avengers up here at the bottom, we've got the uppercase version of Avengers. This is extremely useful to be able to put in any computed property you want into these queries, and they can correspond to an arbitrary EdgeQL expression. In fact, we can, this can be truly whatever you want. You could just, try, I'll try to limit the scope of these examples for the moment. Inside of this nested fetch that we're doing here on actors, currently we're just using this as a simple nested object, but inside of each of these links, we're able to write that also as a function, which means we are able to get a reference to this actor variable here. So if we wanted to do things like filter the list of linked actors by, say, the name, actor.name, I like Chris, and we can see that we're going to limit the results of the fetched actors. Let's see here. Actor.name, I like Chris. Oh, there we go. No one. Oh, right, forgot my parentheses. There we go. There we go. Now we've got our two Marvel Chris's showing up in that link. Now, this is all fine and dandy. Really, where this starts to shine is with the composability of queries that you write with the query builder. So let's go ahead. If you notice here, when we look at the characters in the Avengers, we don't currently have a reference to Thanos, which, as we all know, showed up in the post scene of the Avengers. So that's got to be in here somewhere. So let's go ahead and switch gears here. We're going to be switching away from selections and actually inserting a new person into the database. So e.insert e.person, and that name is going to be Josh Brolin, the actor who plays Thanos. So this is an expression that now corresponds to an insertion query. Of course, we also need to now get the Avengers back. So we're going to be updating it. So const updated Avengers equals e.update, e.movie. And we're going to be adding in that filter, e.up, movie.title equals the Avengers. So this is going to be the set. This now defines the set of objects that we're going to be updating. And then we use the special set key here to actually provide it which links and properties we're going to be setting. We, of course, get auto completion here as well, and all the things we can update. In this case, we're going to be updating actors. Now, we could just do actors : Josh. What this would do is actually overwrite all of the actors that are linked to the Avengers. And so we'd lose all of these other characters that are currently there, like, you know, the whole Captain America, etc. So what we actually want to do is just append to a set of linked actors. We do that with the plus equals operator, and then we're going to pass Josh in there. So let's go ahead and see what the result of this looks like. It's going to be pretty lame. Namely, it's just an object with an ID property. That's because by default, update statements in EdgeQL just return the ID of the object or objects that you updated. So I think it would be fun if we actually put in a query here where we would actually select some properties on this updated Avengers object. So we're going to do updated Avengers. We're going to pull in the title. And then as a demonstration of computed properties again, we're going to do Avengers dot actors dot name, which is a path like you talked about. And what this will return is just the names, a set of names corresponding to the actors that are in this particular movie. And we can see their inferred type there is, we're going to get back an object. It's going to have a title and an array of the actors' names. Let's go ahead and save that, run this. And it failed. Excellent. Live demos for the win. Okay. Let's try. I think I must have, let's go ahead and make this a little easier on ourselves and just fetch the actors link and the name property. Scope does not exist. I'm gonna quit the server. Sometimes it can get a little confused with all the hot reloading I've done in this talk. So we were updating Avengers, passing that into select, and then selecting some properties on it. Interesting. Okay, well, this is a tricky one, folks. Oh, well, all right. I guess it doesn't like fetching actors. So yeah, in case I didn't mention already, the query builder is in beta as of today, and we're going to be looking into this one. So as you can see, when you're writing really complex queries like this, it really starts feeling like you're writing a script, like you're just writing TypeScript code that can do updates and inserts and selects and deletes, and you can just kind of compose them all with, into a very complex single query that does a lot of different things. In case it wasn't obvious, these aren't executing separately. We're not running each of these here. There's no await statement. This is just a data structure that refers to an EdgeQL query. And we're taking that subquery, we're dropping it into this one, and then we're taking updated Avengers and we're dropping it into that final select. All of this actually compiles to a single EdgeQL query that gets executed all in one go under the hood. In fact, we can actually see what that, oh, sorry, we can't do that. You can see with any given query what that generated EdgeQL is going to look like by calling the toEdgeQL method right there. So this is totally transparent. You can see exactly what's going on if you want inside of the query builder. And that's something that we think is very important, and that is going to really unlock a lot of potential in terms of the developer experience. The great thing also about this is the reason we're able to provide these sorts of amazing APIs is because we're compiling to EdgeQL, which is just an amazing target for building sorts of idiomatic APIs in different languages. EdgeQL, because of that graph relational nature, it fits cleanly into object relational languages. So it's really been a remarkable project working on this query builder, and I'm very excited to see what you guys build with it.